Finch Farm is a really unique experiment we have here at Iowa State University. We're doing work with Pivot now on Proven 40 and to determine the potential environmental benefits of reducing some fertilizer and substituting it with Proven 40. We have 48 half-acre plots. Each one of those plots has its own dedicated drainage system, so we can measure the quantity and the quality of water that comes out from the management practice that we overlay on top of that plot.
With this unique trial design, we can do sort of a hybrid research between the big field and a small research quality study. And so we can measure the effects on the nitrate coming in that water. You know, the nitrogen that we lose that is costing the farmers money. Research like this really helps us understand how we can raise the best corn crop we can while minimizing the environmental impact.
Nitrogen has the biggest environmental impact of crop production on the environment, but at the same time, nitrogen is absolutely critical to producing food. Roughly 3/4 of the greenhouse gas emissions from producing a bushel of corn are attributable to nitrogen. However, over time, we expect that proportion to grow significantly.
This research gives us data that's otherwise really hard to get a hold of. It's all something that we know happens, that you lose a little nitrogen and it goes into the water, and of course we don't want to do that, but with this unique setup we can put hard numbers to that and give real results.
2.6 pounds of carbon dioxide are produced for every pound of nitrogen fertilizer we apply, and to grow an acre of corn in Iowa we have to apply about 180 to 200 pounds of nitrogen fertilizer. Nitrate losses from corn and soybean production in the upper Midwest are the leading source of nitrate loading to the Gulf of Mexico, so that's a lot of carbon dioxide. In contrast, microbes can make their own nitrogen. As we begin to value carbon emissions, and as we focus on reducing those carbon emissions, it's going to have a number of benefits. It's going to improve the efficiency of our crop production, so that means greater productivity, less environmental impact, not just for those greenhouse gases, but for the water quality concerns as well. Anything that the farmer does to improve the efficient use of nitrogen is going to benefit profitability and environmental performance.
The data that comes out of this, for farmers especially, they know that when they put this on their crop and put this in their field, then they are positively impacting their community.
This research farm really allows us to understand how the management choices we make when we grow corn and soybeans affect the water quality. We're really excited about the future and the new opportunities that are going to help drive environmental performance of agriculture. As its proportional impact grows, we hope its absolute impact is going to go down. We never really thought about the potential of planting early to reduce nitrogen losses to the environment, but this is one of the really remarkable things that we're learning has tremendous power to reduce nitrate losses. Future generations inspire me. Minimizing the environmental impact per unit of production, that the reality is there's still a lot of people in the world who need more food. And there are things we could do outside of agriculture to reduce our agricultural footprint in places like the United States, where we're very lucky and relatively food secure compared to places like Africa. But these solutions are going to become more and more important as we increase the standard of living and lift the boat for everybody in the world. And that's what inspires me.